All right, guys, we're still looking at derivatives, and we're going to look at the graphs and kind of compare the graphs of the function and then the function's derivative. And so those make two different graphs, and those tell us two different things. So just remember that when f prime of x is equal to 0, then that means that the f of x, the original function, is going to have a horizontal tangent at that point, which also means that you're going to have a relative min or a relative max. And then if f prime of x is greater than 0, that means that the slope is greater than 0, which means it's going to be the graph of the function is going to be increasing. And then if if f prime of x is less than 0, that means that the slope of the tangent line is negative, which means it's going to be decreasing. When by decreasing, that's the original function is going to be decreasing. And then if f prime of x changes from positive to negative, then that means that we're going to have a relative max on our regular function. It also tells us that we're going from increasing to decreasing. So remember, if the slope of the line that's tangent to our function is going to be what our derivative graph is going to be. So then if f prime of x changes from negative to positive, that means it's going to go from decreasing to increasing, which means we would have, so it's going to go from decreasing to increasing, which means we're going to have a relative min. So all these things are really important for you to remember about f of x and f prime of x, because you're going to sometimes you're going to be given the graph of f prime of x and asked questions about f of x and vice versa. So let's just take a look here. So here is the graph of f of x. So this is f of x. And then let's graph some things, a possible f prime of x. Well, what you'll notice is that I'm increasing from these values here, okay? And then I'm decreasing for values here. And then I'm increasing again for values here. And then I'm decreasing for values here. That's decreasing as well. So remember that if it's increasing, my f prime of x is going to be positive and positive, and then if it's decreasing, my derivative is going to be negative. So I'm going to have a positive all the way up until this x value here, which happens to be at, looks like -4. So I'm going to go all the way to -4. It's going to be positive up to -4. And then you can see it's going to be negative up to 1. And then we'll be positive again at positive, looks like 5. So we're going to be positive all the way from -infinity up to -4. And then I'm going to be negative from all these values from -4 to 1. It's going to be negative. And then I'm going to become, and then my graph becomes, or my f of x is increasing, so it's going to be positive again, but then it's going to drop back down to being decreasing from the rest of the way, and that would make a negative slope. So our f prime of x, our derivative graph, could look something like this, okay? It's not necessarily that's exactly, but pretty close. All right, so what we're going to do here is we're going to look at this. This is the graph of f of x. So it's really important that you pay attention to what graph are you given, because it could be f of x, it could be f prime of x. So just be very careful about that. And so what we're going to do is we're going to answer the question. So we're going to estimate or approximate, the value of f prime of 4. So what I'm doing is I'm given f of 3 right here, and f of 5. So I'm going to find this secant line right here. Let's see here. I do a better job of that. So I'm going to find the slope of that secant line. That's going to be pretty dang close to what my f prime of 4 is going to be. So basically, I'm going to find f of 5 and subtract f of 3, and then do 5 minus 3. So f of 5 ends up being 4, and f of 3 is negative 1. And then 5 minus 3. So I end up with 5 over 2. So the slope, so this is going to be approximately f prime of 4. We're not exactly sure what the exact, we could obviously graph it or graph the slope there of this tangent line based on a ruler, but that's not exactly accurate either. So approximately 5 over 2. And then at what values of f of x is f prime of x equal to 0? So where is the slope of my tangent line going to be at 0? Well, those are going to be at your relative min and max. So here and here. So, and one more place, which is going to be right here. So we're going to have, this is going to be at x is equal to negative 4, 1, and 5. So those are going to be relative max or mins. Which means we'll have a horizontal tangent line. And then on what open intervals is f prime of x greater than 0? So that's going to be where is our graph increasing. So let's take a look here. So our graph is increasing on 2 intervals. So our graph is increasing from here to here, and then from here to here as well. So, all right, so this is going to be from this point, these points here, and then this interval here. And it's going to keep going on and on. So we have from negative 4 to negative 1, excuse me, positive 1, unioned with 5 to positive infinity. And then on what open intervals is f prime of x greater than 0? So those are going to be where your graph is increasing. So it looks like my graph is increasing here and here. So this is going to be where f of x, and so this is going to be from negative infinity up to negative 4. And then unioned with 1 to 5. So both of those are going to be there. So you can see our entire domain is taken up by increasing or decreasing, one of those two, except for the part where you have, since these are open intervals, you would not include like 4, 1, or 5, which is where we would have those horizontal tangents at. And then it says, at what values of x does a graph of f of x go from being below the x-axis to above the x-axis? So this is where, so we're talking about the derivative. So basically, this is asking, where does f of x change from decreasing to increasing? Okay, so this is going to be at x equals 1. This is the only time it goes from decreasing to increasing. And then, so that would change, so the f prime of x, so our derivative graph would go from being below the x-axis to above the x-axis. And then what values of x of the graph of f prime of x go from being above the x-axis to below the x-axis, which means that our f of x is going to change from increasing to decreasing. And those are going to be at x equals -4 and at x equal to 5. All right, so let's look at our second example now. So we have the graph of f prime of x. That's what's graphed now. And we're going to be answering questions about f of x, so the actual function and not about the derivative like before. So the graph of f prime of x is graphed over here from -3 to 4. So on that closed interval, that's the only picture or snapshot that we see of the derivative. So on what open intervals is the graph of f of x increasing? So remember, for f of x to be increasing, the derivative has to be positive. So basically, I'm looking for where is the graph of f prime of x above the x-axis. So up here, and so you'll notice that that's going to be between -3 and -2, and that's going to be an open interval. So it's going to be between -3 and -2. So, and that's going to be where f prime of x is greater than 0. So, remember that this graph is showing f prime of x, not f of x. Okay, so now let's look and see where is the graph of f of x decreasing. So remember, I'm not looking at as where is f prime of x decreasing. I'm looking at where is f of x, so the actual function decreasing. And remember, that's going to be anytime it's below the x-axis, the derivative is below the x-axis, the graph of that. So any of those intervals. So we're talking about an open interval, and so that's going to be between -2 and 4. And excuse me, that's not necessarily true. It's actually equal to 0 right here. So we actually need to make rewrite this. So this is going to be between -2 and 2, unioned with 2 to 4, and this is where f prime of x is less than 0. So decreasing is when the derivative is less than 0. And think about that. Also remember that the tangent line, that's what this graph that's what this derivative graph is graphing, is what is the tangent line. So if the tangent line is negative, if the slope of that is negative, then you're going to have something below the x-axis, which would be decreasing, because the slant of that would be downwards. So then it asks for where is a horizontal tangent. So that's actually going to happen at 2 places, because remember, that's where f prime of x is equal to 0. So that's going to happen at -2 and at +2. So x equals -2 and x equals +2. So you would have a horizontal tangent at those 2 places. At what values of x does a graph have a relative maximum? So a relative maximum means that you're going to be increasing. So that means I'm going to be above the x-axis, and then I'm going to start being below the x-axis. So a relative maximum means I'm going to go from increasing to decreasing. So where does that happen on our graph here? Well, these are still and we'll learn about this a little bit later, but these are called our critical points. So when we're looking at the derivative here, so our critical points here at -2 and 2, where we have a horizontal tangent line, we want to see, is it changing? Is it crossing basically the x-axis? And it is. It's crossing the x-axis. Here it goes from increasing above the x-axis to decreasing below the x-axis. So that's going to be a relative maximum. So I know I have a relative maximum there. Then we also have a relative minimum. So that needs to go from decreasing or below the x-axis to increasing or above the x-axis when we look at the graph of that. So what you'll notice is that I've already used up my critical point. I already have a maximum, a relative maximum at -2. So this critical point is kind of out of place. So we need to look a little bit more closely at this critical point right here at +2. Well, it's decreasing. So it's below the x-axis, and then it comes up to 0. So we have some sort of so our derivative is 0 at that point. It's a critical value, but it doesn't change to increasing, so it doesn't change to be above the x-axis. So therefore, there is no relative min. And then basically, we want to say it doesn't ever change from decreasing to increasing. All right. And then what is the slope of the tangent line to the graph at f of x at x equals 0? So I'm going to just basically evaluate this. So this is what's really nice about this graph here is that I can look when x is equal to 0, what is the slope of that tangent line? It's right there at -2. So I'm basically looking at f prime of 0, and that's going to be -2. Since this whole graph is sloping is graphing the slopes of the tangent lines. Okay, so make sure that you kind of keep that in mind because it's really confusing when you have the graph of f of x and then you have the graph of f prime of x, and you're like, so are these related? So they are related, but this is just plotting the points that's the slope of the tangent lines as it changes. And then what is the slope of the normal line to the graph f of x at x equals 4? So I'm going to come over here to x equals 4. And the slope of the actual tangent line is right here at -2. So I'm going to say f prime of 4 is -2. So the slope of the normal line, remember, is the opposite reciprocal because it is perpendicular. So we're going to have a positive 1/2 because because that is perpendicular to the tangent line at 4. So that is answering questions about this graph of f prime of x because I do think that this is really confusing. I think on the AP test you'll see a lot of the graph of f prime of x, and it's going to ask you about f of x. So just kind of be on the lookout for that, making sure that you're noting what graph are you given. So this lesson covered a little bit deeper dive into derivatives and then also looking at the graph of a derivative, which we haven't really talked about. We've looked at equations of that, but we haven't really looked at the graphs. So this is really important. You're keeping those key values like where is f prime of x going to be increasing, decreasing, basically when is it going from above the x-axis to below the x-axis and vice versa. And then you're also looking at where is the slope equal to 0. So those right there are key points that you want to keep in your mind as we move forward with derivatives.